So the first area we're going to be talking about is shape and space, and in specific, we're going to talk about circle geometry. So in grade 9, there are three main things to know about circle geometry, and we're going to start with the first one, the Chord bisector theorem. So the Chord bisector theorem states that if you have a circle right here, this is a circle, it's not a greatly drawn circle, and if you have a random line that bisects or passes through this entire circle, let's just say right here, and you draw a line from the center point of this circle, this overall circle, and draw it down so that when it crosses this bisecting line at a 90-degree angle, so this is 90 degrees or a right angle, then this length, so the place that this bisecting line crosses the circle in the first place, to the line that divides it into 90 degrees, and this part, which is basically the opposite direction of what I just said, so this part and this part of where this line divides this bisecting line right here would be equal. These two would be equal. This would equal this in length. And vice versa, if you have a circle, vice versa, if you have a bisecting line and you draw a dot for the center right there, and you connect this to a point such that this length is equal to this length, so this equals that, you know that this is equal to 90 degrees. So, to draw it a bit more nicer, let's call the center of the circle O. Let's call this point right here A, this point right here B, this point right here where O crosses the axes right here, C. So mathematically, we could write it as, let's write it right here. Mathematically, we could write that if AC is equal to CB, that's not a great B, in this circle, if AC is equal to CB, right here, then angle OCB would equal angle O would equal angle OCA and would equal 90 degrees. Vice versa, if angle OCB equals angle OCA, we know that then AC equals CB. Right there. So let's do a practice problem discussing this idea. Right here, this idea. So the problem we're going to be talking about right here. Okay, so say that we have a pipe. Say we have a pipe of diameter pause it. Right, the first practice question we're going to be doing is, say we have a pipe, pause it. The first idea we're going to talk about with the chord bisector theorem is this problem. Say we have a pipe. Say we have a pipe with some water in it. The water is 18 meters across the pipe. So, what I mean, we have a pipe right here, and this pipe is on its side, just like normal pipes, and there's water right here. Everything below, this is all water. The water right here is 18 meters across. And say there's a point right in the center of this entire pipe, so the center of the circle, and we label it X. If x is 12 meters above the water line, what is the diameter of the pipe? So, once again, say we have this pipe right here with some water in it, so right there. The water is 18 meters across this entire pipe. So this right here would be 18 meters. If x is the center of the pipe, so the center of the circle on its side, and this x point is 12 meters above the water line, what is the diameter of this pump? So we're going to use some things we just learned, and I'm going to erase some of this for now. We know this is 18 and this right here is 12. So since this 12 right here is how far the center of the pipe, so x, is to the water, we know that the shortest distance that this could be would be 12. This also means that this angle right here is 90 degrees. Using the Chord bisector theorem, since this is 90 degrees right here, we know that this length, the center right there to where the x is measured above, is equal to the corresponding other side, so right here. So that means that this line right here, x to the point that it's measured from, divides the length of the water across into 2. Since we know that the length of the water across is 18 meters, we know that one section of here right to here would be 18 divided by 2, which is equal to 9 meters. So we know right here is 9 meters, and just like that, the other side is also 9 meters. So now that we know that that's 9 meters and that's 12 meters, we can use some of the Pythagorean Theorem, which you should have learned in previous years, to figure out what the radius of this pipe is. So let's take this triangle right here. I'm going to draw it on the side. So in this triangle, x would be the center of the pipe, like we said before. This point right here would be the point on the water line that x is measured from to get 12 meters. Corresponding, we know this is 12 meters. And we know from before that this length, by the Chord bisector theorem, is equal to 18 divided by 2 equals 9 meters. Since we also know that this is 90 degrees, we can use the Pythagorean theorem to get this length. By the Pythagorean theorem, this length right here should equal 12 squared. This side right here squared plus this side right here squared, all square rooted. So 12 squared plus 9 squared, square rooted. And this right here is around equal to 144 plus 81, which is equal to, let's do some quick maths, square root of 225. And depending on the situation, you can either use a calculator or just like me, if you just already know, this is equal to 15 meters. So therefore, we know that this length right here, which is this length right here, is equal to 15 meters. Are we done here? Let's reread the questions. If it asks if x is 12 meters, if the length of the water line to x is 12 meters, what is the diameter of the pipe? Notice how it says diameter. The 15 meters we found before is only the radius or halfway of the diameter of the pipe. So when you're doing the PAT, you have to remember to always be reading the questions really carefully, because there are a lot of times where they're going to ask you questions like these where maybe the direct answer would give you a radius, but you have to just tweak it a little bit just to get what the actual answer is asking for. So you could do this, you can guarantee your success by using stuff like highlighters or just boxing stuff like this, keywords, or just underlining, anything that you think will help you remember what the question is actually asking for. So by circle geometry, we know that the diameter is equal to 2 times the radius. And since we know what the radius is 15 meters, we know the diameter of this overall pipe is equal to 2 times 15 meters, which is equal to 30 meters. So we have our answer of 30 meters right here.